So again, same initial setup. Let's take this and let's set it equal to 0. So you've got 6x squared is negative 4. You've got x squared is negative 4 over 6. And you've got, let me reduce that, negative 2/3. So if you square root both sides, you'll notice that there's a negative on the inside, right? So you actually end up with x is plus or minus root 2 over root 3, and there's an I here. And I should rationalize, but before I rationalize, I'm going to point out this is imaginary, right? This is not something that we can graph along with all of our other numbers. So because this is imaginary, we actually just end up tossing it. There are not vertical asymptotes for this case. Now, side note, if you had x squared was positive 2 over thirds, and then you took the square root, you would get x squared. You could actually throw this on a calculator and get an approximation, which is about 0.8164, and it continues on. So if this was positive, if it was real, even though this isn't a pretty value, this is actually, it would be a representation of the asymptote. If you were graphing, I would use the decimal version. If you were just writing it as an answer, I would put root 2 over root 3, and I would rationalize. So x is root 6 over 3. That's how I would write this. And actually, this should be with a plus or minus. So just kind of keep that in mind. There were two ways that this could have played out. Ours had this imaginary value, imaginary I, because there was a negative in there. But if there was a positive, we actually could have kept going with it. So there's no vertical asymptotes. And actually, right? What about horizontal asymptotes? Okay, so again, we're looking at those leading coefficients, leading terms. We've got 12x cubed, we've got 6x squared, so 12x cubed over 6x squared. This time, this is larger, and the denominator is smaller, right? Well, according to our rules, if the degree of the numerator is larger, that actually means that there's no horizontal asymptote, okay? But if it's one larger, so if the degree is one larger, x cubed is 1 degree larger than x squared, which means that we could have an oblique asymptote, right? So in order to figure this out, you divide the denominator into the numerator, and we cannot use synthetic here because this is degree 2. If it was linear, we could get away with it, but we can't. So we've got 6x squared plus 4 going into 12x cubed. I'm going to put plus 0x squared minus x and 0 for the constant. And let me just scoot over so I have some more space. Okay, so we've done some of this before. Remember, our focus here is going to be on the first number. We're going to focus here on the 6x squared and how that goes into each of our terms. So 6x squared times what is this number here? Well, it's times 2x, okay? And then the 2x multiplies times both of these terms here. So that's going to be 12x cubed plus 8x. And actually, I'll have to scoot over because I need it to line up. Plus 8x. So remember, you subtract, which means you change everyone's signs. Okay, so that these cancel out. We're left with nothing there. And then this becomes x minus 8x, and this gives you a negative 9x, right? Turns out we didn't need this, so this is not there, and you really don't need a plus 0. This happens sometimes. So because 9x is smaller, specifically this degree is smaller than this degree, you're actually done. So this is equal to 2x minus 9x over 6x squared plus 4, right? Remember writing that out? The rules for an oblique asymptote say we keep the quotient and we toss the reciprocal. So this is equal to, or the oblique asymptote is y is equal to 2x. And this should be linear. So if you were to graph this, which we'll see an example of when we go through our examples in a minute, but you can use mx plus b as a guide. So in this instance, if you were to graph this, pardon my sloppy graph, you would start here up 2 over 1, and that would be your other point, right? And you would have this dashed line that acts as a horizontal asymptote. So your graph would not cross this, or in general, it would not cross. Okay? Again, getting a tiny bit ahead of myself as far as just extra stuff that we'll see when we actually graph. If you want to know if your graph actually does cross this line, you set the whole entire graph, so the graph, so does it cross? You set the graph, so that's 12x cubed minus x over 6x squared plus 4 equal to that 2x. I'm going to put it over 1, and I'm going to cross multiply, so 12x cubed minus x is equal to 12x cubed plus 8x. And if we move the 12x cubed, cancel, right, cancel, you're left with negative x is equal to 8x. Or if I move this, 0 is equal to 9x. And that's not a true statement, right? So because this is false, and we can cross it out, this is false, that tells us it does not cross. If you got an actual number out of this, so if it was like x is equal to 3, it would cross where 3 is on this line. Whatever that point is, it would be possible for your graph to cross through. Like I said, we'll get to those examples. You'll see some in your homework, so you'll run into them. They're not very common, but they do show up every so often. All right.